Hey everyone, welcome to our study guide. It is time to get ready for tomorrow's quiz. So I wanted to go through the answers with you so that you feel ready to rock tomorrow's quiz. All right, so let's go ahead and start on this thing. 3 parts of every atom. They're called the subatomic particles. You've got your protons, your neutrons, and your electrons. Protons and neutrons are both located in the nucleus. That's the center of the atom. And they constitute, or they make up, all of the mass of the atom. So we say each one has a mass of 1 atomic mass unit, or AMU, okay? Electrons are so tiny, we say they have feasibly no mass. They're a mass of 0. And they are located in energy levels, in orbitals, in rings, in an electron cloud, somewhere outside the nucleus. Okay, so those are the ones that are not in the center. As far as charges go, neutrons are neutral or no charge. I'm gonna put a 0. You can write no. Protons are positively charged, and electrons are negatively charged. Okay, so if you can fill out this table, that means that you really understand everything you need to know. And the rest is just applying it. So which particle determines the identity of the atom? That's the proton. If you look at the periodic table, the identity of the atoms is based on the atomic number. That's the number of protons. Protons and neutrons contribute to mass. And which 2 particles have charge? Well, you see them there, protons and electrons, okay? So you can see protons play a role in all of these things, and neutrons and electrons also play important roles. All right, so here we go. Can you fill in the blanks without using the word bank? I know you can, but I put one there for you too, just to double check. So isotopes are different versions of the same element. If they're the same element, they must have the same number of protons. Otherwise, they'd be different elements. But they have different numbers of neutrons. You got it. And so therefore, their mass is going to be different. They're usually written by their name and then their mass. So we talked about this in class. We had carbon 12, carbon 13, carbon 14, all different versions of carbon. All carbon atoms have 6 protons because they're atomic number 6, but different numbers of neutrons. All right, that's isotopes. So far we have told the difference between types, mass, and charge. And now we've told the difference between isotopes. We are rocking on this. Let's talk about ions. Ions are when an atom has lost, positive ion, or gained electrons. So when the number of protons in an atom equals the number of electrons, that means they have equal parts of positive particles and negative particles, then the atom has no charge or is electrically neutral. However, when an atom has different numbers of protons and neutrons, it has a net charge and it is called an ion. If an atom has more electrons, more negative particles than positive ones, protons, it is a negatively charged ion, also known as an anion. If it has more positive protons than negative electrons, it is a positively charged ion, also known as a cation. All right? So now we did the charge of an atom. Well, we talked about it. Let's actually apply it. All right, so number 8 says, can you fill in this table? You will need your periodic table for this part of the study guide. You won't need it for the quiz. In fact, you won't be able to leave the page of the quiz and still earn a score. So everything you need will be given on the quiz. But let's go ahead and fill it in. We've got atomic number 38. The atomic number on the symbol is at the bottom. And as always, atomic number tells us the number of protons. So we must have 38. It's got to be strontium. Strontium is number 38, and it has 38 protons. What about the mass? The mass is also told to us in this symbol. It is the one at the top. So the mass is 88. Now remember, protons plus neutrons equals mass. So 38 plus what is 88? 38 plus 50. So there's 50 neutrons in there. Okay, they told us the charge of the strontium ion is +2. It's a +2 charge, which means it must have 2 more protons than electrons. And that means it must have 36 electrons because 38 is 2 higher. All right, tell me about atomic tell me about atomic number 35. What do you know about it? It's down here. It's bromine. It has 35 protons. It's used to clean hot tubs, the way chlorine right above it is used to clean pools. All right, so its mass is 79. That goes at the top. And so how many neutrons does it have? 44, right? 35 plus 44 gives us 79. Nice. This one also has 36 electrons. Interesting. I wonder why. So what does that tell us? It has 1 more electron than proton. It has 1 more negative particle than positive. So it must be a negatively charged ion with a charge of -1. All right, last one on this little table. We're looking at something with 13 protons, which means it must be atomic number 13. It is aluminium, as the British say, or aluminum here in the USA. Either one is fine. We're going to put 13 down here at the bottom. And can we figure out its mass this time? Sure we can. We know it's got 13 protons and 13 neutrons. Add them together. Mass is 26 of this isotope. There are other isotopes of aluminum that have a mass of 27. And we know that because on the periodic table, the average atomic mass is closer to 27. All right, let's see if we can figure out the number of electrons. We know it has a +3 charge. They told us that. That means it must have 3 more protons than electrons. So 3 more per 13 is 3 more than 10. All right, nicely done on that, guys. Now let's look at the final page here. Ooh, I like this question. Which diagrams represent isotopes of the same element? Okay, so remember, you know what an isotope is. Atoms of the same element that have the same number of protons, but different number of neutrons. So I would go through and see, do a little count here and see how many does each have. I'd give myself a little tally, protons, neutrons, and electrons. This one has 4 protons, 4 neutrons, and 4 electrons. Ooh, that's easy. All right, B has, I see 4 protons. How about neutrons? 6 neutrons, and I'll put electrons over here, I'm running out of space, and 2 electrons. Okay, what about C? C has 1, 2, 3, 4, 5, 6 electrons. So this is a different element identity altogether. This is carbon. The other 2 were atomic number 4, beryllium. Okay, so 6 is 6 protons, 6 neutrons, and 1, 2, 3, 4, 5, 6 electrons as well. Maybe I'll erase my marks. Oops, I don't want to erase the whole thing. So they don't look like other electrons. All right, in D, we've got 4 protons again. This time we have 5 neutrons and 2 electrons. And then in E, we have 5 protons, 5 neutrons, and 5 electrons. Okay, So we've got a little count here, and if we're looking for isotopes, we're looking for the same number of protons, but different number of neutrons, different mass. So which ones have the same number of protons? A, B, and D all have 4 protons. And so if we wanted to go a step further, we could write the symbols for them. They are all beryllium atoms. They're all atomic number 4. But they have different masses, right? A has a mass of 8 because 4 protons plus 4 neutrons. B has a mass of 10 and D has a mass of 9. And then let's just go ahead and do charge since we're here. A has a charge of 0. Remember, you don't have to write the 0. You can leave the 0 off, but I'm putting it there just so you know I didn't forget. B has 4 protons and 2 electrons, so it has a charge of +2, and so does D. Okay, because this kind of helps us answer the next question as well. So you want to actually explain how do you know? I've talked it out, but you'll actually write something to let us know. I know that they're isotopes because they're the same atom, they're the same identity, they have the same number of protons, they're the same atomic number, however you want to say it, but they have a different number of neutrons or a different mass. Either one is great. For ions, B and D are both ions. What about C? Is C an ion? No, 6 protons and 6 electrons. What about E? Nope, 5 protons and 5 electrons. So B and D are both ions. They're both positive ions, +2 ions. And how do we know? They have 2 more electrons. Sorry, they have 2 more protons than electrons. Or you could say they've lost 2 electrons. Either one is correct. Remember what group beryllium is in, right? We'll get more into that later next week. All right, for number 11, you can draw any 2 different neutral atoms of your choice, okay? So I can't do this one for you, but I did give you a checklist over there on the right. So, you know, just follow that checklist and you should be fine. And then number 12, write a quiz question you'd like to see. Don't forget to include the correct answer. So I'll be looking at those and maybe you'll see one of your questions on the quiz, or maybe we'll save it and use it another time. All right, thanks everybody. Let me know if you have any questions. Talk to you later. Bye.